I'm Phil, and I'm continuing to have a look at using MIDI bits for music. And I'm going to use the MIDI control bit this time. So let's have a look at that bit and what it is. So this is the module. And if you look at it, we'll just bring across the picture, you can see that it's got two sockets. On the right, there's a USB MIDI input output, and on the left there's a MIDI in. Now, the difference here is the MIDI in only uses a 3.5 millimeter connection to a traditional 5-pin DIN socket. So you've got a couple of options there, but it doesn't cover all options. So let's have a look at it. This allows us to control MIDI devices from the MIDI bit. So you can use electronics and you can use software on the microbit array. And you can also use software from programs like Ableton Live. Covers the full note range from C2 to C6. And we're talking about changing the voltage to an octave, and it's rated as 1 volt per octave up to C6. So when you generate a note C2, you're generating a voltage of 0.2 volts. Okay, so there's a little bit of the detail, and there's the TRS cable that's needed to connect it to MIDI devices. Okay, so let's have a look at some of the projects. I've done previous projects with CodeBit, and this particular version is going to Ableton Live. So that one worked okay, and there's Ableton Live. But the one that I want to focus on today, there are two of them. One's using a Microbit computer in the Littlebit chain to control the MIDI in or MIDI out. So that's in the second one. But the first one doesn't use a computer at all. So we might actually have a look at that one. And we look at the arrangement, and we'll just close down the other branches of our mind map. This is what the arrangement looks like. So on the desktop, I've got the Microbit electronics on the bottom right. There's a Korg Volca, and there's a speaker, and I've got another box that allows me to connect traditional MIDI cables to USB MIDI. Okay, so we might look at that arrangement that we've got. So just going right up to the top, there's in a little bit more detail of our MIDI arrangement, or of our keyboard arrangement. And we've got a spectrum analyzer on this. Okay, so let's have a look at what that does. What our objective is here is to control the Volca FM using MIDI in. And I want to explore MIDI converters and have a look at adding a extra sequencer. So overall, these are the modules I'm using. The Korg Volca FM, using a few MIDI bits, and here they are here, the microsequencer, the keyboard, the MIDI in, and a split arrangement that allows me to add a couple of branches to the microbit. I'm using a numbers bit as a voltmeter, and I'm also looking at the spectrum, the audio spectrum. I've got power supplies, and I'm using a DAW MIDI USB host with a donor connection. or a donor speaker. So this is the overall output, and we might go across now and have a look at the construction of that. So there we are. We've got our branch for our Littlebits right on the top with the microsequencer connected to the MIDI, and that goes via the DAW MIDI USB host to our Korg Volca FM, and we're using the MIDI in for that. Our second project, so the operation of that went quite well. We could adjust our microsequence and for both timing and voltage, and we're able to adjust the control for our Volca FM using MIDI in. So we might close that branch of our mind map, and we'll have a look at the other project, which is using a microbit, this time with MIDI in. And we'll just close everything down so you can see the desktop and all the other components. So there's each branch of our mind map. And our desktop looks like this. So we're just using MIDI in this time. And the MIDI in's coming from a keyboard. And it goes into our Littlebit electronics, which is an analog synthesizer that depends on the MIDI note coming in. So let's have a look at the branches of all of that. Right on top, we've got our Key 25 keyboard. And here's one branch of our Littlebit electronics, where we've got two oscillators connected as an FM synthesizer, then onto a speaker and to a voltmeter. And here's a slightly different arrangement where we're using microsequencers on the input chain. And here's our microbit computer with the View LCD. So you can see some of the arrangements there. So what are the objectives here? We want to explore MIDI control again, but this time it'll be MIDI in to the microbit. And we'll be using the MIDI notes, and the MIDI note numbers will go to our software. So hardware-wise, similar to the previous one, but we're using let's have it. There's the arrangement that we've got this time. So we've got a Littlebits with a microbit adapter on that. We might go across now and have a look at that. Here we're looking at the Korg Volca FM with Littlebit electronics and microbit. So here's the Korg Volca FM, and we're going to use the MIDI in. So it uses the older 5-pin DIN socket with a MIDI cable. And for microbits, we're going to start off with the Littlebits and add the microbit computer to it. So we need an adapter, and the adapter allows us to have 6 ports. On the left, we've got the input, and on the right, we have the output ports. So on the input, we're going to add a keyboard, and we can also add proximity sensors. So in this arrangement, we not only get a keyboard for our musical synthesizer, but we can also have a theremin computer with both pitch and velocity control. And we need some power, and there's a number of ways of doing that. On the output, we're going to have the MIDI bit, and I've got a voltmeter that also shows the voltage. And to our MIDI bit, we use a USB connector to a DAW MIDI USB MIDI host. And that allows us to go and use the traditional MIDI connection with the DIN plugs and cables. Then we add our microbit with to our microbit adapter. And I'm going to add an additional LCD display to the microbit so I can debug the program a little bit easier than just relying on the LED array on microbit. And here's another arrangement. And so instead of having the keyboard, I've got two microsequencers, and I've also got a MIDI in. So what we're doing here is that we've got microsequencers, and also we're using a MIDI keyboard from the APC Key 25 Compact. And that's also using the DAW MIDI as the connection to our MIDI in. So you can see there's a difference here. We're using the MIDI in uses a 3.5 millimeter TRS cable to a MIDI socket. And everything else is the same, except on the output in this case, we're setting up the MIDI bits as an analog synthesizer with a simple oscillator, filter, and speaker. And we can add to the oscillator and filter with an additional oscillator, delay, and envelope control. So we could make this output a bit more complicated. And here's a different arrangement where we've got both MIDI in and MIDI out, but we need a more complicated arrangement here. And I'm actually using two of the DAW MIDI USB hubs rather than the one that I've shown here. So here's the software using Microsoft MakeCode or Microbit. So the overall software is composed of a number of modules. Some of these are functions. There's the two main ones, the on start for initialization, and in the middle we have the forever, and the rest of the program relies on modules for both input and for various functions. So let's have a look at these in detail. We might zoom in on the startup. So we'll go across, and here you can see that on startup, we're setting the program name and showing that on the microbit LED array. Then we initialize, and that initialize function is right below it. So we're setting 3 modes for the program, and the initial mode is number 3. And we set up the other parameters. DAC stands for digital to analog converter, and the maximum on our microbit is 1027. The minimum is going to be 0. And we also do the same with the beats per minute and the MIDI max and the MIDI min. And we set up our beats per minute, the initial ones. And we're going to use an extension module for our LCD display. It's a 128 by 64 display. And you can see the parameters that I can set on that here. But I'm turning it on, setting it for big fonts, clearing the display, and showing the program name on the first row of the LCD. And we might go across and have a look at the forever. In forever, we show which mode we're on the LCD and the beats per minute. That only really has significance when we're using the sequencers. And we've got 2 of those. We read the first sequencer into port 1, into port 2, it goes the second one, and the keyboard goes into the 0 port. And depending on the mode, we then go and play the keyboard or the sequencer or the stored sequencer. So we might have a look at those. In that setup, we also call up the stored sequencer. So here's our song, for our stored sequencer. And these notes are in an array. There are 16 of them, and the numbers are MIDI notes. So we're starting off with middle C. And we might go to the other ones. When we play our keyboard, we just simply set the oscillator note to the keyboard, and then set that out to the analog pin 15. The others are quite similar. When we play this sequencer, instead of the keyboard, we just map the sequencer to our oscillator, and we then send it to the same port. Here are some of our other pins. When we want to change the beats per minute, we just simply press the logo button. And if we want to change modes, we press button A, and that will take us through from 1 to 3. And we can reset everything with button B. And we might have a look at the stored sequencer mode. So this is an interesting one where we use that array and cycle through the array and map the MIDI notes which are in the array to the ADC values from minimum to max. And then we set the oscillator note, goes to port 15. And I've got a couple of extra serial messages that helps me debug the program. And that's the software for our MIDI bit, or our MIDI control in. This is the Korg Volca FM, and you can play it with its own touchpads, or alternatively turn on the sequencer, and you can change the sequence. So we have now are now simulating a music box. I've extended it so that we get an input from Littlebits, and Littlebits has an alternative keyboard, and it sends the signal to a voltmeter. So you can see that as we select the keyboard, we're changing the voltage, but we're also sending it to a MIDI output. And the MIDI output goes into the MIDI in on the Volca FM. In addition, we have the sound going via splitter. One arm goes to the FM display, and I'm using a microphone input for that, again using Littlebits. And the other arm goes to a Donna portable speaker. And if we play the keyboard, the signal is sent via FM to the Volca FM. Now we're going to change the keyboard and put in a microsequencer. So when it shows the LED on the potentiometer, that means that the voltage from that potentiometer goes off to the voltmeter and also sends a note out via the MIDI controller. So let's put up the volume and listen to that. And if we turn down the speed, or turn it up, it'll go faster. We can replace the sequencer with a proximity sensor, and that acts like a theremin. So if I put my hand over the sensor, it will change the and that's using a proximity sensor as an input. And another sensor is the pressure sensor. So if I put my finger on the pressure sensor, I can select various voltages. Here we have Littlebits set up for MIDI in. So we've got a MIDI in module, and when it gets the voltage, it then shows it on the voltmeter and sends that into the Microbit computer. So overall, we've got a branch here. This is where our MIDI in is, but we also have two sequencers over here, and we've got and they are all feeding analog voltages to our Microbit computer. So the other side of the Microbit adapter and computer is this one. And we've got a Microbit LED array, the push buttons. We also have an additional screen that's very useful for debugging the program. And the output, there's only one output, and it's feeding analog values along this chain. So we have two oscillators set up as a ring modulator, and we have a speaker and a voltmeter. And the keyboard is sending the MIDI notes via the USB MIDI host. So that's the arrangement for our MIDI in to Littlebits. So let's have a look at the configuration in operation. So what we're going to do is just go through the scales. We've got our Littlebit electronics over here on the left, and we've got a MIDI in, and the MIDI is coming from our keyboard. So as we go through our keyboard, so that's in keyboard mode, or mode 1. Now if we go to sequencer mode, we go to 2, and it's getting the values for our notes from the sequencer. So you can see the, and I can adjust that. And that's our MIDI in working. In this mode, our MIDI synth is being driven by a microsequencer. So there's only 4 steps in that, and you can see that over here. And what we've added is a little bit more to our analog stage. So there's a voltage comes out of here, and that voltage is fed by the Microbit computer over here. And we have 2 oscillators and a filter. The filter's got a cutoff and a peak, and that then feeds into our speaker. And there are voltmeters at the output, so we can see the range of voltages which are being created. So we might just increase that so you can hear what it sounds like. And that's our synth using Littlebit electronics with a MIDI in, but in this case here we're using the microsequencer, and the analog stages providing the sound, converting the voltages from the Microbit computer so you can hear it on the Littlebits speaker.